Hi everyone, I hope you are all doing well and welcome to the Mastercam the complete course. As you know, we have covered the module number 2, which is all about the 2D design and toolpaths, and we have covered the topics including the creating 2D sketches and geometry, introduction to toolpath and chaining manager, milling depth cuts, milling lead in and out, milling multi-passes, milling additional parameters, toolpath type, tools and holder, and the toolpaths, 2D toolpaths including the facing, pocket, slot, contour, drilling, model chamfer toolpaths. Now it's time to test your knowledge. So it's a module 2 quiz, and we have some multiple choice questions on my screen. And what you have to do is you have to pick the right answer to question. So we'll give some time, around 10 seconds. You have to pick the right answer to question. So let's get started. So the first question is, in Mastercam's chaining manager, what does the term chaining refer to? Option A, organizing tools based on their functionality. Option B, linking machining operations in sequence. Option C, arranging the order of toolpath operations. Option D, creating a continuous path for tool movement on the part geometry. So the right answer to question is option D, creating a continuous path for tool movement on the part geometry. Now let's move towards the another question, which function is not typically performed by Mastercam's chaining manager? Option A, defining the starting point for machining. Option B, creating complex toolpath strategies. Option C, optimizing toolpath for material removal. Option D, generating G code for CNC machines. So the right answer to question is option D, which is not suited to this question. So the option is generating G code for CNC machines. So let's move towards the other question. What is the purpose of using lead in and out in Mastercam milling? Option A, to increase the spindle speed. Option B, to reduce tool wear. Option C, to improve surface finish. Option D, to control the toolpath entry and exit. So the right answer to question is to control the toolpath entry and exit. Lead-in specially defines the entry of the cutting tool into cutting path, and lead-out means that after perform the machining operation, the cutting tool will exit from the machining tool path. So the next question, what is the purpose of using multi-passes in Mastercam? Option A, to reduce machining time and improve efficiency. Option B, to increase the complexity of toolpaths. Option C, to decrease the accuracy of the machining process. Option D, to simplify the CNC programming process. So the right answer to question is to reduce machining time and improve efficiency. The purpose of multi-passes is to get to toolpath to increase the efficiency, give more surface finish to the workpiece, and increase the machine to cutting tool life also. Gives more smooth surface and shine surface to the part. So that's why we used in multi-passes operation in the Mastercam. So the next question is, which Mastercam toolpath type is commonly used for creating pockets and cavities within a part? Option A, facing. Option B, pocket. Option C, slot. And option D is drilling. So the right answer to question is option B, pocket. So pocket milling is commonly used to create pockets and cavities within a part. These pockets may be in a square form, in a round shape, or in an irregular shape. So let's move towards the next question. What toolpath type in Mastercam is best suited for creating holes of various diameters in a part? Option A, facing. Option B, pocket. Option C, slot. And option D, drilling. So the right answer to question is option D, drilling operation. So to create new holes, we use drilling method in Mastercam. Next question is, which Mastercam toolpath type is suitable for cutting narrow channels or groove into a part? Option A, facing. Option B, contour. Option C, slot. Option D, drilling. So the right answer to question is option C, slot milling operation. Next question is, which toolpath type in Mastercam is primarily used for creating flat surfaces on the top of the part? Option A, facing. Option B, pocket. Option C, slot milling. Option D, drilling operation. So the right answer to question is facing operation. Typically, the facing operation is the first operation we perform on the milling machine. The purpose is to create a reference point. For the reference point, we need our workpiece to be flattened completely. So that's why we use facing operation. And the tool we use for face operation is face milling cutter. So the next question is, so I hope you understand all these things and you did well. So thank you very much.